The topic of the presentation is General Introduction to DACs. The contents of the presentation will go as follows. First, we will have the introduction. Second, working of a DAC. And at last, we will look at some applications. We know there exist two types of signals, which are digital signal and analog signal. Digital signals are discrete. They are in the form of high and low, or we can say 0 and 1s. Mainly, the digital signals can be found in the computers and microprocessors, whereas the analog signals are continuous, are everywhere in the nature. Some examples can be temperature, sound, etc. In electronics, there are needs where one signal is needed to be converted into another in order to fulfill a purpose. That is where a DAC comes into play. A DAC stands for digital to analog converter. The digital to analog converter is used to convert input digital signal into some analog output corresponding to the input values of the signal. It acts as a bridge between two different systems, one being digital and the other being analog in nature. Now let's have a look at how a digital to analog converter works. Here we have a block diagram of a digital to analog converter. The process of converting a digital signal into its corresponding analog signal starts by setting the reference voltage value. By setting the voltage reference value, we determine the range of a digital to analog converter. If the voltage reference value is set at 5 volts, the analog output from the DAC we can get ranges from 0 volts to 5 volts. The output generated voltage is either less than the voltage reference value or it's equal to the voltage reference value. After setting the voltage reference value, we provide digital signal in form of binary zeros and ones to the input of the DAC. As a DAC is a multiple input and a single output converter, we provide multiple binary values in the input of a DAC and a single analog input is generated at the output. The accuracy of a DAC then therefore depends on the number of input it receives. The more the number of inputs, the more the accuracy of the output signal will be. The binary input values are assigned their weights. Like here is a 4-bit input. The topmost is the least significant bit and the bottommost bit is the most significant bit. After the binary inputs are provided, each binary input is passed through a voltage switching process. If the binary bit value is 0, the switch for the particular bit is turned off and grounded. Whereas if the input bit value is 1, the switch is turned on to be further passed through a resistive network. Based on the resistive networks DACs, we have two types, weighted resistor and R2R resistor. In a resistive network, the bit that were 1 are passed through a resistor to generate some voltage drop. So as the switch is closed for the bit that were high, some current is passed. As the current flows through the network through the resistors, assigned resistance value depending on the weights of binary inputs, there is some voltage drop. For the resistive network has the most important part in a DAC. This part is which is actually converting the digital inputs into an analog output value. At last, all the voltage drops through the resistive network for each bit value are summed up to generate a voltage signal. That voltage signal received at output is the corresponding analog value of the provided input digital signal. The output received can further be passed through a low pass filter to remove the noise in the signal. We can also use an amplifier after the filter depending on the application in which we need the DAC for. So this was the explanation on how a basic DAC works by the help of a simple block diagram. As a DAC generates an analog output, it is needed wherever we want an analog output from a digital system. Such an example is audio systems, where the digital data from a computer is converted into analog signal through speakers in form of sounds. Other fields for application of DACs are communication systems, video systems, industrial automation, medical imaging, test and measurement instruments, and many other such applications. So here comes the end of my presentation on the general introduction to digital to analog converters. Thank you.